8 today. We're joined by Ross again. So if just a reminder, if you do have any questions, pop them into the chat box. We can get to them at the end of the session, or if you want to unmute yourself and ask your questions at the end, we can do that too. But delighted to have you back with us, Ross. So just over to you today.
Hey everyone, welcome back. You'll be absolutely sick of listening to me by the end of this, but BIM Bites 8, it's the second last one of the series. We'll have one more, which is the clinic. The clinic was supposed to happen on the 1st, which is Friday, but unfortunately we're going to have to postpone that until perhaps the following week. Unfortunately, I won't be available Friday, but yes, just a couple of more minutes so until kind of everybody has joined us. Today, BIM Bites 8, we have stage 3 and 4 in the design stage again. It's this kind of part 2 measurement. It's focusing on the MEP, mechanical, electrical and plumbing element. This one in particular, I think, is of interest to everybody. And we'll try and get into a little bit in the nuts and bolts. And like last week, we'll also have a look at the method of measurements and see how they fit into under ICMS. I just stuck a few slides in there today just to hopefully give everybody kind of more clarity between ICMS and the method of measurements. But I think perhaps there's something in the clinic to dig into further there next time. But yes, so BIM Bites, design stage 3 and 4, which we're getting to detailed design now, just before tender on a client-led design. MEP measurement, I will jump through. You can see that my presentations are quite standard. Again, the message is always the same, collaboration, collaboration, collaboration. And it'll be quite important, I think, for this. I don't know, and maybe you guys will have a better idea than me in terms of mindset. Is this a big shift for us as quantity surveyors? We already collaborate, I would say. We already are in discussions and meetings and communication with the design teams and supply chain and all of the stakeholder groups. So I'm not sure if it's a major mind shift change, but perhaps in terms of that open transparency, I think maybe will be a little new for us. We're not often as open as we would like to be, especially around the commercial stuff. But often that is also is led by our clients as well. So lots of talking with the design teams. BIM Execution Plan, super important, as we mentioned before, to get our requirements into the BIM Execution Plan. And really driving these standards for us going forward within ICMS. But let's dig in a bit. And again, under this particular delivery strategy, we're looking at the concept design stage 3, technical design stage 4, really getting into the detail now. And I must say, this is really where the mechanical, electrical and plumbing, the MEP, really come alive with the level of information that is in the models for them. And I think this is, personally, I think this is where we get huge benefit from. No one's like sitting down measuring pipes from diagrams and trying to figure out heights of buildings and the vertical sections of pipework. It's just a nightmare. And this is really where the models come into their own, if we can get that information from the design team within the models. So understanding the different levels of information, as we discussed last time, moving along the project life cycle, we now know that the different disciplines deliver their level of detail and level of information at different stages, even though the industry has tried to standardize that LOD 200, 300, 350 at the different stages. The reality is we just don't get that from all of the disciplines uniform at each of those stages. It's just not possible because the design development of the project doesn't happen that way. We need to let the traditional design evolution kind of develop itself throughout the project lifecycle. So for us, we need to be aware of what that LOD and LOI is along the different design stages. So again, for mechanical and electrical, we'll jump into this LOD level. And for different systems, it is often quite different, because a lot of some of the mechanical and electrical systems are functional requirements where we wouldn't actually model them, or the design team don't actually model them. Security might be one, for example. Yes, you might get the location of sensors, etc., on ceiling plans, but you're not going to get cables. You might get the location of the security boxes, the fireman's box, for example, for fire safety, etc., but they're not going to model the entire system for you. That becomes a functional requirement for the specialist supplier in many projects. And it's those smaller systems, those low voltage, I would say, that are often not modeled in the level of detail as other systems would be, especially when we come to the likes of that electrical and security elements. So let's bear that in mind. We might not get that promised LOD level 350 at detailed design stage for some of those lower systems. The BMS, the building management system, that's another one. It might purely be functional, based around certain scopes, certain points per equipment, certain points per location within the particular project, etc. And it could be a specialist supplier nominated by the client as well. So we'll need to keep that and bear that in mind as we're beginning to work through the project with the architects and the engineers, of course. But ideally, we will try to define as much as possible in the BIM execution plan at the early stages. Even at that stage, we should be identifying with the client if they have any specialist suppliers, specialist agreements that they have with the supply chain. Of course, this will differ from public to private sector, as you guys well know. But that is important to understand, I would think, at this early stage, because it will define what we will be doing at the latter stages of the project. You guys are the experts in that. I don't need to tell you that. So the LOD, as we mentioned before, here we're focusing on LOD 350 purely because that's what's being defined for this detailed design stage. If you ever see an LOD 400 or 500 at a design stage, generally the BIM execution plan, I would argue, is wrong. Someone really is not understanding what they're requiring when we talk LOD 400, 500. That's as-built stuff that you will receive from the contractor at the latter end. I'd be interested to hear if you guys have ever come across that on your projects. In the earlier stages of the development, we've come across it all right, but it becomes pretty obvious pretty quickly that it's not achievable to develop that level of detail, or even necessary. As parametric design comes in and artificial intelligence, I think we'll be able to get this information in our models during the design stage for certain components. But again, a broad brush minimum requirement for all disciplines of a LOD 350 at the end of a detailed design stage, it's not exactly correct. We need to understand that as we develop through. And this is the challenge. When you look at all the standards in the industry, no one really explains this to you. This is something we figure out on the projects ourselves. We might understand it, of course, from the traditional design delivery model, process. Let's not get terminology confused there, but the design development process. And we need to use those understandings in a practical sense. Like we can't expect more than is traditionally delivered. Again, same diagram as before. We're looking at different models, unfederated for different disciplines. As we mentioned the last day, you might have a minimum of 5. You could have as many as 10 or even more. Here we've identified on some projects, we've got some unfederated models for mechanical and electrical alone. As you can see identified on the list here, main electrical, fire safety, hot and cold water, ventilation, cooling, foul drainage, external services, all different unfederated models, generally on major projects, more than likely industry, pharma. You'll get specialist discipline leads developing these systems, meaning that more than likely they'll be modeled separately as unfederated. Again, we'll try to understand that in the earlier stages of the project, so that for us at least it is clear what to expect. And then from here we set up our weekly, as mentioned before, or weekly or bi-weekly meetings with each of these disciplines to discuss again what has been done, what's in the plan. Let's look at the models, quality of information. Does the BIM execution plan make sense? Also, what is ICMS and how do we expect to deliver our cost estimates and cost plans? Often you'll see that the engineers and architects are interested to hear that. Sometimes the structure is different in Ireland. The engineering consultants take on the responsibility for quantification of the engineering elements. I can see that changing in the future. If in one sense, really, because we need, as QSs, we need to deliver full project package, in my opinion. Secondly, for carbon and LCA is going to, and full life cycle assessment, LCC is going to require us to be able to, or to have accessibility to these quantities. And if we need them to do those calculations, we should also manage the quantification of those disciplines as well. Also interested to hear your guys' opinion on that. More than likely for the smaller projects, it'll remain traditional, but for the larger projects, I think there's going to be a shift there if that's not already happened. And you'll be dreaming about this bloody diagram at night now, you know. Yeah, communication, it's our responsibility to know who the modelers are, because the modelers will be different for each discipline, each organization. It's our responsibility to know who the discipline leads are for each system, so that we can communicate and integrate with those individuals, building that relationship and that camaraderie for the project. And of course, the communication flow between disciplines. In terms of communication, something we haven't mentioned before, and it's not really related to our quantification process, but it's related to the communication between disciplines. And we would expect as QSs to be invited to that communication flow. If Revit is being used by all disciplines, often you will see that it's a BIM 360 Autodesk's cloud-based solution that is used. There's other platforms out there like Plannerly, for example, that helps with setting up the minimum standards in terms of the BIM execution plan management and delivery. Some of these platforms are super good for setting that baseline of understanding and then managing and developing the design towards that. We as QSs want to be in that conversation. That's not just a design communication flow, that's also a communication flow for us. So when we're assessing models within Costex or Qubit or whatever, and we see mistakes and errors, rather than filling out our traditional RFI list on Excel or requests for information, we would open up an issue in one of these platforms like BIM 360 and or Plannerly and raise that with a particular discipline. So we're now coordinating or structuring our communication flow in a digital way with all the disciplines, so they see visibility to this as well, and also so our clients see visibility for this as well. But we're tracking communication flow in that singular cloud-based activity, meaning it's much sharper, it's much more instant. You're not waiting till the end of the week or the end of the fortnight to submit these RFIs. They're happening instantly, which is really an advantage to the project, again helping with the communication. I don't think we mentioned that before, but if you have any questions relating to that, please raise them at the end of the presentation. But back to our models and modeled information as last week. I'm trying to think of the day of the week. It's only Monday. God, that's not a good thing. Models and modeled information. So we're looking at the MEP models, and we'll go through. Principles are the same. As I mentioned before, the only difference when it comes to MEP is that it's system-based. System-based, not in how they model, but in how we need that information. And we'll look a little bit later at the methods of measurements and ICMS and the requirements for these systems. But from a modeling perspective, the engineers do not have to follow systems. They just model. They could be component-based, like the architectural engineers models. So I'll show you a little later what I mean by that. But extract again from the dimension groups from Costex here. This is all the information relating to, again, if you look on top, you see all these unfederated models. This is the mechanical kind of hot water, hot, cold water systems. And you can see here system types, sanitary, and then you get your pipes, insulation, and pipe fittings, insulation, and pipes. As a minimum requirement, I would argue that that's what you should be looking for. You can, of course, go into more detail in the models, but that will depend on what we're looking for. So families from Revit, this is the type in terms of what are we talking about. Reference codes, again, more than likely uniclass if it's in Ireland and the UK and going forward. Obviously, as I mentioned before, there's many different coding structures out there depending on the country and location, jurisdiction, etc. But the process, the principle is the same. That doesn't change. And in the system elements, as I mentioned before, this particular project, we required that the design teams broke the project down in systems, because that's the only way that we can actually understand the total cost of system, and the only way that we can use it for benchmarking in the future. ICMS also requires it, so we'll come on that a little bit later. But this is just an example, again, using Costex. You could be using Celebri or Navisworks, doesn't really matter. The principle is the same. What we're doing is clicking on a system here on the left, and on the right that system is shown. All components that come, all the children underneath that parent of industrial waste is shown in the model. If it wasn't system-based, we would be clicking on pipes, pipe fittings, for example, and it would show all pipe fittings for the entire project, not the system. This is where systems become important, because, of course, we need to know the cost per system, but the modelers don't need to model it that way. And I think that this is probably the key takeaway from us. When it comes to method of measurement, heights of hangers, all of that stuff, that becomes a little challenging within the models. You can pull those heights out, but they won't, the modelers will not model in that way. Likewise, the modelers will not model hangers, for example. Now with some of the advancements in design automation, they can model hangers, etc., except for ventilation systems and pipes, etc. That way you can pull quantification if the method of measurement requires it. But you need to understand that at the beginning, what way that the engineer is going to model. Will they model hangers, etc., within your distribution elements? Likewise here, looking at sanitary systems, same principle applies as we go through. What we're talking about here is now, in a click of a button, we have visibility on systems. Prior to this, we were looking at 2D diagrammatic. It was virtually impossible to understand really the system. You have your horizontals, but what about all your verticals? They became challenging to understand that. Now we can, as I mentioned before, we can have really super quick takeoff in terms of main distribution elements, main equipment, etc., from the models, that can be quite good accuracy, as long as we're understanding the modeling process and that method of measurement. A small example here would be going from Denmark, for example. They have two standards of modeling. One is they'll model a pipe up to the joint, and the joint and bend or angle or elbow is modeled separately. Another one is they'll model right to the center line of the joint model, elbow or bend, and the bend, elbow or joint is included in the unit price of the pipe. So you have to have that conversation early with the disciplines to make sure that they're modeling in the way that you will also quantify here. That might be different here in Ireland and the UK. We'd have to look into that at the beginning, and that's a conversation to be had with the engineers. Also interested to hear your opinion, your experience in those matters. Plumbing distribution, of course, the larger the projects, the more complex they are. This is where I absolutely believe that modeling services, MEP, comes into its own in terms of that very quick quantification. You can see it all the way down along the left-hand side, again, relating to the different systems, whether it's in industrial pipework, sanitary, domestic water, etc. So we can really begin to isolate these systems and pull. This is quite a large manufacturing facility on the project, or as this example at the moment. And then, of course, we have identified in the naming convention the coding number related to what the coding structure you're using, whether it's Uniclass or what have you, the pipe material, pipe size, and system. It's basically, you get quite a lot of information quickly then from the models, as long as the engineers are modeling in that way, all to be defined in the BIM execution plan at the beginning. Just an example then of ventilation. Different approaches to ventilation. We like to look at each individual ventilation system, so that every system under a AHU unit, depending on the number of AHUs you have on your particular project, that'll give us a very clear understanding in terms of benchmarking and metrics for cubic meter of air exchange per hour per system when we get these prices back from the marketplace. Other approaches is in the method of measurements, you price each mechanical unit separately, and all your ducting is included for all systems. We'll look at that a little bit later, but we like to look at it here system based, and the modelers can do that. It's not a lot of additional work for them actually, because they're modeling each component anyway. They're just allocating it to a system type, and so we need to try and define that process at the beginning of the project. So again, what you're seeing here is on the plumbing element. It's system based, very similar pipes, different pipe materials and sizes used across systems, so they'll be using the same component but just in different systems. For mechanical here, and the ventilation principles are the same, whether it's a rectangular duct, a round duct. Those material types or component types are shared across different systems. So from a modeling perspective, I think it's not an issue to break these out, just allocating the system. Yes. And then the electrical. The electrical can vary, I would say, depending on complexity of the project typology you're working on. If it's high-end pharmaceutical manufacturing, you're going to get a lot of electrical cables because they're high voltage, bus bars, etc. They'll be modeled on kind of lower complexity buildings, offices, hotels, residential. You're not going to get as much as that of that modeled. But here you're looking at cable trays, busways, and switchboard units, etc. Modeled in the electrical, and a lot of the secondary fixing also will be modeled, the likes of switches, as I mentioned earlier on, security sensors, fire alarm sensors, sockets, etc., etc. You can actually see down here on the left-hand side what we're looking at. We're currently looking at conducts under the routing, and later down along you can see electrical equipment and fixtures and devices, lighting devices, etc. All of that will be modeled, but of course we need to verify the quality of those models. Something like in all models, we're going to run into, well, what do we usually come across that becomes challenging for us? Yeah. So often we require or suggest that we look at certain elements, and it was like the same in the architecture and construction. It's having this conversation with the discipline leads about information that's important to us. So again, drawing tags. Often the tags in the drawings are not the same as the tags in the model or that reference code. We need to somehow link them, and there needs to be a key within the design information to link it. It can be done in Revit, and that can be embedded on the 2D drawings once they're cut. It's an important conversation to have up front, because this is something that will be challenging over time, I think. Insulation to the pipes, also an interesting one, as we mentioned in terms of model sizes. A while back, 850 megabyte model. Once we removed certain parameters in IFC, insulation being one of them, we were able to reduce the size of that model dramatically. And again, other areas like the generic models and caseworks. I have an example of that in a second. I have examples for each of those, of course, like the last time. External, internal, it's not covered under the coding structure of using Denmark, but Uniclass will or might. Client deliverables and underground installations. Underground installations is a bit challenging. As I mentioned the last day, well, I hope I mentioned it. often that's civils works, that's services in the ground outside of the building, and landscaping, etc., might not be modeled. It might still be 2D and until those disciplines catch up. But it's something that we should be discussing, especially if it's a specialist discipline doing external works, for example. So yeah, installation for what pipe and what size. You can see here it's undefined, but we can bring it in later here under our requirements. So this is, again, we're not doing this, of course. This needs to be defined within the models. We can't add information to our models if it doesn't exist in the models. That needs to be communicated with the discipline leads and the engineers on the project. And what's interesting about this is that this is the same conversation we're going to have on every single project. It's the first one that's going to be the most difficult. And then once we move to our next project, we will already have the knowledge built up. We'll already have these conversations. You're kind of rinsing and repeating as you go through each project with new stakeholders. And it's always the same. It's always new stakeholders. We know that. If you're lucky enough to repeat, carry out an additional project, a second project, it's the same stakeholder group, client, architect, engineer, you're really into a good place, because what you've all learned in the previous project, when it comes to this, you're really just implementing. Again, some of these conversations you don't even need to take. But our experience is that the discipline leads change regardless whether it's the same stakeholder groups that you're working with, even if it's a repeat project. You know, the discipline leads change, the modelers change, people move around the organization. So standardization in communication is ideal, because for you as the QS, you're just pulling that go-to pack, you know, and you're going, well, this is what we're doing. This is our standard approach to this. This is what we want to implement. Oh, have we looked at this, guys? We need to make sure that ghosts are indicated like this, and client deliverables are indicated like that. And, you know, have we got the parameters we need when it comes to installation on the pipes? Yes or no? So yeah, I think once those first few projects come in, I think it will be a rinse and repeat work, the same way quantification is rinse and repeat, isn't it? There's nothing new in it. Following our method of measurement is a standard approach. Generic models and casework. So generic models, an example for generic models might be the importation of a structural model into an architectural model. That's a generic model. We don't want to know anything about the structure in the architectural model. It's there for placement. We should never measure off that. The same principle might be as you might have the architectural model in the services just for locations, etc. We don't care about that. Because that model might be out of date. We focus on the model the discipline lead gave us the most up to date. But getting these elements and understanding them is important, because generic models and casework come with no quantities. So there's no quantity generated by default. So we'll export this from the model, but there'll be no quantity with it. They need to be added as an export parameter or a custom parameter when doing IFC. So and we can easily have this discussion with the modelers. They'll know what you mean when we talk about generic models and casework within Revit. And of course, we also need to be honest with them as well. You know, maybe we don't know a lot about it, or we know something we need to ask about. And as we layer on our experience and knowledge on top of it, this will become a very easy conversation for us in the future. Installations underground. Obviously, we need to measure them separately to the systems that are above ground. As I mentioned before, under the ground, I would say under the building is usually not a problem in terms of modeled information. We often get that. That's no problem. It's the services underground externally outside the building that are often not modeled. But it's project dependent, it's engineer dependent, who within the stakeholder group has responsibility and control of that. And so every project in that sense will be slightly different, I would say. So there's just some examples of the models, unfederated, the systems we're talking about, the system-based structure that we really need models to be in when it comes to MEP, and as well as standardizing in terms of information then. So pipes and material types and what defines a different element in the model, that also needs to be discussed sometimes. And this is more uncommon, I would say, but sometimes the design disciplines might look at a pipe based on its sizes rather than its material type. So you might have some disciplines that will focus just on pipe sizes because they're looking at clash detection only, whereas we absolutely need to know whether that pipe stainless steel or PVC or whatever. We need to know what that material type is. So that needs to be defined early and discussed with that discipline lead, especially if the engineering practice aren't used to LOI level of information and are only used to that level of detail, which is geometric element for clash detection. So an important conversation again to have early so that they understand, and for them it adds a layer of quality to their design information, because they can layer in that material type automatically into their drawings and their diagrams, etc. So it really becomes much better quality for as in design material. But nevertheless, it very well could be an awkward conversation at the beginning, especially if they don't understand why they need it. So that's really it in terms of examples of the different discipline models and the structure of how models and the level of information we expect to receive. Again, it's very high level and generic. I'm trying to show you, we could really dive into the complexities of them, but I think if we apply those basic principles, we're going to get to real quality from the design information. And so, like the last time, in relation to architecture and construction, we're not just standardizing the level of information coming from the models and processing that. We also need to standardize our cost structures internally, so that we become more data focused and we become more interested in how we can improve the service, not from just a quality of delivery, but a service in terms of how we produce and prepare information. And you guys all know ICMS at this stage. ICMS 3 is out. Lots of standards, links within the SCSI and our previous BIM Bites sessions. But I just wanted to kind of dive into something here in relation to the method of measurement. As we mentioned before, ICMS is just a cost breakdown structure. It is not a method of measurement. You have to look at your own jurisdiction to understand which method of measurement best suits you, whether it's ARM4 or NRM or whatever. If it's civils, it obviously is different. It really depends. But ICMS should be your skeleton that sits the spine of your cost breakdown structure. But just considering mechanical electrical for a minute and looking at mechanical NRM2. NRM2, in terms of the method of measurement, doesn't actually break down in system type. And please, if anybody thinks differently and I'm incorrect here, just raise your hand or get involved in the conversation. But if you look at the primary equipment, that's based on system per number. But if you go down to 3 and look at the pipework, that's based on material, finish, joints, backgrounds, etc., fixings, etc., per linear meter. Not necessarily system based. And we would prefer, especially when it comes to the ventilation, each ventilation system based on that AHU unit, that supply and return of air. We focus on a system because it gives us a very good benchmark for cubic meters per hour air exchange for each system type. And as you begin to build that, we get a very clear understanding. So systems, in my opinion, always much better. But if we consider ICMS, when it comes to mechanical, is absolutely system-based, as you can see here. It's whatever in terms of 19 different systems is what it's trying to define here, including your testing and commissioning. So definitely system-based. We will need our cost breakdown structures and bills of quantities, etc., to be system-based on if we were to report an ICMS format, which we will need to next year for public procurement. Electrical, the same, system-based, kind of high voltage, low voltage, main distribution. Then you get all into the low voltage elements like securities and BMS systems and internal staff paging, etc., etc. but I think we'll do a session on ICMS anyway, as part of the BIM clinic. But just to give you an idea, and then if you look at ARM or ARM4 supplement, that is system-based when it comes to, this is the mechanical element, system-based. Slightly different to ICMS, I would say. Of course, if we go back, ICMS is the cost structure. These are the systems you should absolutely be following. And then underneath that, you embed the method of measurement for system. So underneath your system, you have 2, 3, 4, 5, 6, 7, 8 as level 5. Underneath that, you have this is level 6. Underneath that, you have the different element measurement, I would say. So ICMS first, NRM embedded underneath that as a system of method of measurement for each system type. Yes. And of course, we've always kind of been saying from the beginning that when you begin the project and you do your rough order magnitude and you develop into your cost plans and estimates at each design stage, you're building towards an end product, which is the bill of quantities. So ideally speaking, you're starting with that same structure, cost breakdown structure you intend to deliver at tender stage. You're just adding and layering in the detail of information as it develops throughout the project life cycle. That means you're not starting from scratch at the end of detailed design going, okay, now we need to produce a BOQ. You have an awful lot of the work done running up to that moment in time in relation to that structure, linking of model elements, revision, qualification of models, and obviously communication with our discipline leads, etc. And just for the discipline leads themselves, the BIM execution plan, what do you expect to be doing at these 2 stages? Well, we expect either at that schematic, that could be stage 3, we would expect a square meter price benchmarking for some of the systems. This might be the systems that are functional requirement, and or quantification and unit price for the systems that are designed, like the ventilation systems, the distribution for electrical, etc. And of course, a detailed design, we would expect that everything is at this point is quantified and unit priced in preparation for your tender estimate and your bill of quantities. But that is it for me today, everyone. Thank you again, and that's I would say the last BIM Bite. I really hope that that you all got some kind of value to take away there, at least to start thinking in this way about what needs to be done. Where should we look at in terms of further developing training, etc. What software systems maybe we use. If you have any questions like that are still unclear for you, please write to me on LinkedIn. All I'll do is I'll give you my honest opinion. It'll be up to you guys to make your mind up on that. Often the hardest step for companies and people is to understand what software should we buy. I would say do not buy Revit licenses. Wait, because they're super expensive. There's workarounds and everything as QSs there's many other things that you can do. But I think that's it from me. As I mentioned before, contact information is there. Actually, do you know what? I never actually checked to see does these work. This is going to be interesting. Jim, I don't know if you took any of those out. Do they work? Oh, they do. Super. Technology is great. But that's it for me. Any questions from anybody? Ruth, perhaps there's something in the chat there.
They haven't come into the chat just yet, Ross. So just if anyone would like to pop it in the chat or just unmute yourselves.
Jump in, yeah.
Hi, Ross. It's Jim Stone here.
Hey, Jim.
Thanks again for the presentation and for all the information you've given us today. It's much appreciated, and it's given us a very good overview and detailed understanding of the role of the PQS or QS in general vis-a-vis BIM. In relation to the M&E, I'm just wondering regarding the schedule of builders' work connection that we normally produce when we're measuring the bill. Is there scope or facility within the BIM model for the automatic generation of the said general schedule of builders' work connection?
Connection with holes and openings and so on.
Yeah.
So what we've done in the past is we've used clash detection reports to generate our openings and holes within walls or surfaces or structures, whether it's decks and whether it's in situ or precast, etc. So we've used those kind of clash detection elements. often, so far, we haven't seen design teams designing in, you know, fire protection, sound protection, all of that into openings within structure and across. It really comes down to what the design team are going to provide for you. But clash detection is the closest that we've got to an automated output on that.
Yeah, but potentially there is scope there to extract that information from the models, I guess.
Yeah, so like our other elements we discussed last week, the models are going to give you some information, but not all in accordance with your method of measurement. But for sure, there's scope to extract some of it. Yeah. Actually, another, just on that, Jim. Another example is like painting, for example, is not measured. Not modeled. But we use room volumes to generate the quantity for painting in terms of square meters for different rooms. So there's a whole pile of workarounds. To speed up your process that might not be visible in the model when you go to look at it and you go ask, where the hell's my skirting board, for example? Oh, we're not modeling skirting board. That will take us too long. Perimeters of rooms, you can derive the model the quantity quickly from that, following the room schedules.
Yep, sure. Thank you for that. And my next question is in relation to the old proverbial center lines, apart from girds, but center lines. So if you take your bog standard cavity wall, outer leaf, inner leaf, the modeler, again, you know, when you click on an entity, like for an external wall, come back with a quantity, but of course we want a center line.
We do.
So I'm just wondering, is there scope for the modeler to allocate a line, what we know to be a center line? And from that, then when we click on it, Sinead or center line quantity.
Yeah. So there is scope within the models to do that, to say what quantum you're taking from, whether it's external surface, internal surface, or center line, for sure. So your method of measurements will dictate that. That's a conversation with the design team, I would say. I don't have the knowledge on that, but one of my team members will, for sure. What I'll do is I'll ask them and get them to write a little note, and we can send it out, Ruth, to follow on to answer that question. But for sure, there is a possibility there within that requirements.
Yeah, and that's something that could be included, I guess, in the schedule of requirements that the QS will put into the BEP.
Absolutely. Yeah, absolutely.
Okay, great. And my final question then is, you mentioned about the ICMS, the International Cost Measurement Standards. But then I also see a document, or if not a document, a separate document, a reference to the International Construction Measurement Standards. So I get a bit confused when people say ICMS.
You're confused. So what happened?
Am I talking about here?
So originally, and that's a great question. Thanks very much for asking this one. Originally, it was called International Construction Measurement Standards. And when you look at that, you go, oh, it's a measurement rule. Excellent. So that means that NRM and ARM are gone. And so they were getting feedback and going, so we have a new measurement rule. That's wonderful. And everyone's going, no, this is just a cost breakdown structure. Oh, no, but it says it's a measurement rule. No. So they had to change the name a number of years ago to remove that. So what you're talking about is the exact same thing. It's just a name change, I think 2 years ago, when revision 3 came out. Prior to that, it was called the construction measurement, the cost measurement. I can't remember which one. So yeah, your exact confusion was the reason that they changed the name.
Okay, and then obviously to close out in the ICMS, as you say, it's a cost breakdown structure only, and then each particular member state or whatever will come up with their own method of measurement, whether it's RM5 or NRM2.
Correct.
Yeah. Okay, got you. Yeah, great. Thanks, Ross. Appreciate that. Thank you.
No bother. I do know in the UK, for example, the RICS had brought ICMS as the main cost structure for all works now. The National Building Standards has been replaced by, and most probably, and this is only in my opinion, I don't want to see this in the press tomorrow morning or anything, most probably that's what will happen here too in time, I would say. Yeah.
So just for clarification there, are you saying, with the RICS, the Building Cost Information Service, we'd have, we'll say element 21 or element 19 for substructure. They might have element 2A, 2B, 2C. So you say now that they're moving from that into the ICMS.
Mary, you can jump in there if you know better.
Yeah, yes. Can you hear me?
Just about, Mary. Yeah, you're very low.
Yeah, just to clarify, Jim, yes, the ICMS has already been, the templates for it have already been done. and we will be starting from the beginning of January. So the OGP will be following the ICMS.
Yeah, so I think what Mary's saying is ICMS is replacing what you're talking about, those national building elements of 21 and 19. Officially, I'm unsure actually, Jim, so we'll have to look into that and maybe get a statement out from the SCSI on that, so everybody is clear about really what's happening with ICMS and national building elements. And
yeah, I know the ICMS is replacing the national standard building elements, but my related question from the RICS perspective is the ICMS also replacing the RICS equivalent of our element 19? I think it's 2A or 2B and that kind of stuff.
We'll have to look into that one, Ruth. If you might take note of that, please, and we'll dig into that and get something out to the group here as a follow-up.
Yeah, absolutely.
Yeah.
Maybe
Thanks,
for
Ross.
Thank you. Bother. Maybe for the BIM the workshops that we do, we can get a note out to everybody just to get a clear understanding of that. Yes.
So we have a question that's just popped in there, Ross. So contractually, if the model is for information only, how can it be relied on to give a QS quantities?
Good question. Ideally speaking, all drawings that are produced are cut from the model. So the model is the center point of information for the architects and engineers' output. So we can trust the model more than we can perhaps trust the quantity surveyor's ability to measure manually off 150 or 250 2D drawings. So contractually, the drawings take precedent for sure, but they should be cut from the model. Often what we're seeing at the moment is, for example, pre-planning, everything's done in 2D, and then when planning is approved, it goes to 3D. I believe that over time, this is what has happened in Denmark, over time, the modeling will become so efficient in-house in the architects and engineers organizations is that they'll model from day one, as we mentioned before. They won't do 2D into 3D. So I would say, even though the model is for information only, it is far more accurate than having 10 or 15 QSs measure manually on 2D off drawings, I would argue. But that remains to be seen.
Hi, Ross. Can I just add something to that question, if I may?
Sure, Jim.
I would say that notwithstanding whether it's 2D drawings or a BIM model, notwithstanding all of that, at the end of the day, PQS is responsible for the accuracy of the quantities based on the method of measurement, full stop.
And yeah, you're dead right there. So I would say that, well, it comes down to your own individual principles, I guess. At the moment, I can see that why 2D is preferred. It's preferred because we understand the process. The reason 3D isn't preferred is that we haven't really got into that process yet, especially if we talk about these BIM bites we've been having the last 8, digging into the information quality and understanding that that's going to take us time. Like, we wouldn't expect anybody to be coming away from the BIM bites going, I understand it all now, our next project's going to be awesome, we should do it in 3D. That's not the reality. The reality is it's going to take you the next 2, 3, 4 projects to get up to that speed of communication and understanding, and until you guys begin to see what's good quality model and what's bad quality model. Until we get as far as that, then maybe the question will change, I guess, in terms of accuracy of quantification. The other side to it is, if the model is given at tender stage to the contractors, they more than likely will quantify from the model, not from the drawings, because of time. So they'll be qualifying your quantities based on the model, but you will be modeling from 2D, which is correct. So your communication with the design or the contract becomes a little bit more challenging if you have, you know, quantity verification, depending on the procurement strategy and type, etc. Quantity verification or claims. You're almost better quantifying from the model, verifying quality of information, making sure accuracy is there, so the contractor can use that. It speeds up the process of everything for everybody. Just some food for thought there.
There's no other questions there in the chat, Ross. Might just remind everyone that recordings from all of our other sessions are available on Moodle. So in preparation for our BIM clinic, if anyone wanted to watch back any of the content, you have access to it. If you can't remember your Moodle login details, just let myself or Savannah know and we'll get them back across to you.
Excellent. We'll leave it at that and give you your 9 minutes back, or if I'm even following the right time, 10 minutes back. Geez, even more. Enjoy the rest of your day, everyone, and your week. for that matter.
Great. Thanks, Ross. Thank you.
Thanks, everyone.